Subset. When I say one set is the subset of other, it is possible only when all the elements of the set A is in the set B. Rationals cannot become irrationals and irrationals are completely different from rationals. 0 and all positive real numbers are called as non-negative real numbers. Every set is a subset of itself. We can write only the empty set inside the power set of an empty set. Hello everyone, a warm welcome to one and all. This is your Shruti ma'am lecturing in Vidhyaashram. So in this session we are going to study remaining part, that is the types of sets. In this session we are going to study about the subset, intervals of subsets of our power set and universal set here. Now in previous session we have learnt about empty set, finite set, infinite set and as well as the singleton set. Now what do you mean by subset? So subset, when I say one set is the subset of other, it is possible only when all the elements of the set A is in the set B. Suppose I say A is a subset of B. If any element A belongs to A, that means A should belongs to B also. So here I have taken an example here. Let A is equal to 1, 2, 3, 4, B is equal to 1, 2, 3, 4, 5, 6. Clearly you can see here the elements of A, that is 1, 2, 3, 4 is contained in B also. They are the elements of B also. That is why we say here A is a subset of B. So generally we can also say that the set of rational number is a subset of real number. We know that real number is a union of rational as well as irrational number. So when I say it's a union of rational and irrational, clearly both sets, that is the rational as well as irrational number, are the subsets of real number, because all rationals are also reals and all irrationals is also reals. So that is why we say that if set A is said to be subset of B, then every element of A is also an element of B here. Now we have a term called proper subset and superset. What do you mean by proper set? So let me take an example here. Set A is equal to 1, 2, 3. It is a proper subset of 1, 2, 3, 4. Why we call it as like? Here clearly A is a subset of B, but A is not equal to B. The set which is clearly a subset of B but it is not equal to B, or exactly lack with only one element from the subset. Suppose, let me take one more example. X is equal to A comma B and Y is equal to A, B, C. So when I write X as AB, clearly you can see AB is a subset of ABC. That is, X is a subset of Y, but X is not equal to Y. In this case, we call X as a proper subset and Y as a superset. That is, the bigger set containing more elements is called as the superset and the subset is called as the proper subset of given set. So here we can take A is a proper subset of B, or we can say B is a superset of A. So here in terms of subsets, we have very important thing to note that every set is a subset of itself. Suppose I take set A as set 1, 2, 3. Clearly we can say this set is also subset of 1, 2, 3. So clearly you can see here 1, 2, 3 contains in A. So every set is a subset of itself. And the second point is here empty set is a subset of every set. That is, empty is subset of A. So empty means there is no elements inside the set clearly. So it can also be a subset of 1, 2, 3. So the set which does not contain any element is also a subset of a given set. So that is why we can say empty set is a subset of every set. Now mathematically we know that natural number is a subset of integers, because integers contain natural numbers, and when we go in like this we can say integer is a subset of rational, rational is a subset of real number, and irrational is a subset of real number. Why? Because here rational is separate. When I say real number as one complete set, clearly we can divide them as rational and irrational. So not every rational number is irrational here. The number which is rational cannot become irrational. The number which is irrational cannot become rational. But the union of these two is completely the set of real numbers. That is why Q is a subset of R, J is a subset of R. Next thing is, the total number of subsets containing n elements is 2 power n. How many subsets can be created from a given set? We can create 2 power n number of set, which you will study later. So suppose I have an element like A and B. So how many subsets can be formed with this set? That is 2 power 2 elements. That is, we have 2 elements here. Totally 4 subsets can be formed. Like that, how many elements are there inside the set is considered as n element, and number of subsets can be represented in the form of 2 to the power n there. Next, let A is equal to 135 and B be an odd natural number less than 6. When I say odd natural number less than 6, so they are 1, 3, 5. This is the set. Clearly you see here, A is a subset of B because 135 is also element of B and B is also subset of A. 135 in B is also subset or the elements inside the A, that is 135. So from both sides it satisfies, that is A is a subset of B, B is a subset of A. Whenever these two conditions are satisfied, we can clearly write A is equal to B. Thus, this is one more definition you can use for the equal sets. If A is equal to B, that means A is a subset of B and B is a subset of A. Next, we have here a set A with A, E, I, O, U and set B with A, B, C, D. Now here, when I say A is not a subset of B, I can give a reason here because E does not belongs to B. E does not belongs to B. So every element of A should also be an element of B. But here A is the only element which is in B. E, I, O, U is not inside B. That is why we say A is not a subset of B. Coming or checking towards from the other end, is B is a subset of A? No, it is not a subset because other than A, B, C, D does not belongs to A. Therefore, B is not a subset of A here. Now, here we have a question. If A, B, C are 3 sets, if A belongs to B and B is a subset of C, is it true that A is a subset of C? When I say B is a subset of C, that means every element of B should present in C also. So, let me take these condition. A belongs to B. Let me take set A as element A. Now, set B contains A means this A should be inside the set. That is, A belongs to B means I need to write set A itself inside the set B. So, therefore, element A with the set and one more element I will take here. So, here clearly you can see A belongs to B. A belongs to B means A is an element of B. So, here A is element of B, not a subset of B. Now, when I say B is a subset of C here, that means both A and B also belongs to C. So, when I say this implies here set A, that is set A also an element of C and also B belongs to C here. So, this gives us A belongs to C. When I say belongs to, then A is again an element, not a subset. So, we can take this example that it is not a subset. So, clearly we can write A is not a subset of C, it is only the element of C because B contains A as an element. Therefore, A is element inside set C, but it is not a subset of C there. Next, make correct statements by filling in the symbol subset or not subset in the blank spaces. So, you should see the pairs given here and you should fill the proper symbol inside the blank spaces. 2, 3, 4 is a subset of 1, 2, 3, 4, 5. Next, A, B, C is not a subset because A is not contained in this set. Every element of the first set should be in the second set, then only we say it is a subset. X is a student of class 11 of your school and student of your school. Yes, class 11 students is a group of students inside your school. So, therefore, it is a subset. X is a collection of all circles in the plane. X is a circle in the same plane with radius 1 unit. No. So, this is the bigger set. Circles in a plane represents all type of circles, but here you have only the circles with unit radius. So, therefore, this is the smaller set where we cannot write subset. X is a triangle in a plane, X is a rectangle in the plane. So, triangles cannot form a subset for the rectangle, so therefore, it is not a subset there. Examine whether the following statements are true or false. We need to verify it whether it is true or false. A and B is not a subset of BCA. Here is one set, here is one set. They have given it is not a subset, so therefore it is false. Actually, it is a subset of ABC. AE is a subset of collection of all alphabets, ovals in English alphabets. Yes, it is a subset, so therefore it is a true statement. Next we have 1, 2, 3 is a subset of 1, 3, 5. It is false because 2 is not inside this set. Element A belongs to the set ABC. It is false here. So, instead of belongs to, if they have given a subset, it is true. But they are telling that this set belongs to this set. We can't write a set belongs to another set. We need to write it. You should consider here set A as an element. When I say set A as an element, this should be in this form, like element A belongs to the set A, B, C. So, this statement is true, this statement is false. Either it should be replaced with the subset symbol or it should be written in this form. Now, we take a subsets of real number. What are the subsets of real number? We know that a real number system is a bigger number. So, here we have divided them into rational and irrational number. Under irrational, you have an integers. Within integers, you have whole numbers. Within whole numbers, you have natural numbers. And again, natural numbers can be divided into prime numbers, even numbers, odd numbers. Multiple types of subsets can be formed in terms of real numbers. So, the subset of real numbers are many. So, majorly we will divide the number system as rational and irrational, and under rational number we can have integers, whole numbers, natural numbers, even number, prime numbers, odd numbers, etc. So, all these are the subsets of real number. But always remember, Q cannot become a subset of J or J cannot become a subset of Q. This is not true, because rationals cannot become irrationals and irrationals are completely different from rationals. Intervals as subsets of R. So, many sets are written in the form of an interval. For example, when I say an integer value -3, -2, -1, 0, 1, 2, 3, here I can write how many elements are there inside the set. So, therefore, clearly you can see 1, 2, 3, 4, 5, 6, 7. We have 7 elements inside the set. So, it is an infinite set. When I am writing the real number system, I cannot write the elements as -3, -2 because there are infinitely many real numbers between -3 and -2. When you observe the number line, you always write the integers in the number line. But when I say real numbers, it includes fractions, irrational, whose values come in between these value, come in between these integers value, and there are infinitely many real numbers between any two integers. That's why I can't write them separately. So, to write the real number system in the set form, we use a symbol of interval form. That is, we will write like this. When I say the real numbers from -3 to +3, I will use the symbols like this. We are writing all the numbers from -3 to +3. So, that means it includes all the numbers from minus 3 to plus 3. It may be 0, it may be 0.5, root 3, root 3 by 2, 1 by root 2, any type of rational, irrational decimal fractions, it will include from minus 3 to plus 3. So, the real numbers are always represented in the set form using an interval form here. Now, let's see the type of intervals we use in the system of real numbers. First, we have an open interval. What do you mean by an open interval? So, whenever any numbers are written in the form of an open interval, it means we need to write the number only between those numbers, not including that number. That is, an open interval denoted by a comma b is all the points between a and b, but a and b themselves do not belong to this interval. When I say from minus 3 comma 2, I am taking all the numbers from minus 3 to 2, but I am not including minus 3 and 2. So, after minus 3, it may be minus 2.999 something. Until there, I need to take the real numbers. When I say 2, I can include 1.99999. So, that 2 will not be taken as interval point here. So, now thus a comma b. So, symbolically a comma b means it's a set where x lies between a and b. So, we have already written this in the set builder form. When I say the numbers between a and b, you should write only the numbers between a and b except a and b. So, here is an example I have taken, minus 3 comma 5 in the form of an integer. So, if you take this in the form of an integer, not real numbers, if you take minus 3 comma 5 in the set of integers, then I can take minus 2, minus 1, 0, 1, 2, 3, 4. I cannot include 3 as well as 5 here. When I say 2 comma 7, you need to write only the numbers between 2 and 7, that is 3, 4, 5, 6. So, like this, you cannot include the end points of an interval here. Next one, closed interval. Again, the interval which contains the end point also. So, the interval which contains the end points also inside the set is called as a closed interval. So, here we will write this in this form. That means, since we are taking all the values of x between a and b as well as a and b, we write here the symbol less than or equal to, less than or equal to. So, therefore, here is an example I have taken. So, closed interval minus 2 comma 2 means I need to take minus 2, minus 1, 0, 1, 2. But when I write minus 2 comma 2 in terms of open interval, I have only 3 elements, that is minus 1, 0 and 1. So, this is the difference between open and closed interval. So, in open interval, we are not considering the end points as the element of a set, but in closed interval, we will consider the end points as an element of a set. One more example, 3 to 8 means all the integers from 3 to 8. So, this is an example of integers I have given. The intervals of R, that is real numbers, cannot be written in this form because we need to include all the decimals between 3 and 4 also, where we cannot include it because there are infinitely many real numbers between 3 and 4. Next, semi-closed or semi-open interval. So, as the name itself, when I say semi-closed, you are including the end point. Semi-open, you are excluding the end point. So, wherever closed bracket comes or a big bracket, square bracket comes, you need to include the end point inside the set. Whenever you have an open interval, you need to exclude that point from the set. So, therefore, here is a closed and open interval of this form. When I take 2 comma 7. So, this means I need to write all the elements. This is how I will write the real numbers. I need to take all the numbers from 2. I am including 2 here, but excluding 7. So, that is why we need to write less than or equal to. Since we are including 2, we are not taking 7 there. So, this is less than. So, this is how we will write real number system. So, this is for real number. When I say same 2 comma 7 in the set of integers, when I take 2 comma 7 in the set of integer, then the set elements will be 2, 3, 4, 5, 6. We cannot include 7. So, this is how we will write the real number system in terms of intervals and set builder form. This is the integers where we can write the number of elements in set. Now here let me take an example, minus 3 comma 2. So when I say minus 3 comma 2, we are not taking minus 3 but we are taking 2. So therefore it is a collection of all those number where x lies between minus 3 and 2, but for 2 you need to put the less than or equal to symbol. The same example in terms of integers if I take, then I need to leave minus 3, I need to start the set from minus 2, minus 1, 0, 1, 2. Here I need to include the set. So this is how we will write the half closed, half open or semi closed, semi open intervals. Now there are very important points to the note. So as we learned subsets in the form of a finite set also, we can learn the concept of subset in terms of real numbers or integers or in any number system. So here minus 3 comma 5 means here I need to take all the numbers from minus 3 to plus 5. So when I say minus 3 to plus 5, excluding the point minus 3 to plus 5, and when I say minus 7 comma 9, I need to take all the points from minus 7 to 9. Clearly minus 3 comma 5 is also a subset inside the sub B. So therefore we can write here A is a subset of B. That is, all the numbers from minus 3 to 5 also belongs to minus 7 comma 9. They are inside the set or they are inside the interval minus 7 comma 9. Therefore we can write the interval A as a subset of B. The next thing is the set 0 comma infinity defines the set of non-negative real numbers. When I say real numbers always lies from minus infinity to plus infinity, the maximum and minimum value. But when I exclude all the negative real numbers, I should start the interval from 0. So 0 and all positive real numbers are called as non-negative real numbers, and it is written in the form of this interval, that is closed 0, open at infinity. Next, the set minus infinity comma 0 defines the set of negative real numbers here. So here when I say negative real numbers, we should include open interval here. So from minus infinity until 0, not 0, until 0, all are negative. So therefore this is a set of negative real numbers. And the set minus infinity comma infinity defines the set of real number. When I say set of real numbers, in the interval form, it is minus infinity to plus infinity in the open interval form. So that is the set of real numbers. Next, length of an interval. So the length of an interval is defined by B minus A. So always here A is less than B. Remember, always A will be less than B. Therefore, the length B minus A is called length of any interval. For example, if I say minus 3 comma 5 here, then 5 minus of minus 3, that is 8, is the length of the given interval. Thus, B minus A denotes the length of any interval. So now, let us write the following in terms of intervals. We have the first question, x is a collection of all real numbers because they have given x belongs to real numbers, minus 4 less than x less than or equal to 6. Clearly this set, we have minus 4 here. Let us write down the endpoints. But what about the intervals? Here I need to put open interval, here I need to put closed interval because I have less than or equal to symbol in the set builder form. Next, x belongs to real number. We need to write the endpoints minus 12 comma minus 10. What about the intervals? Both side it is less than, so therefore it is open interval. Now let us write the intervals in the form of a set builder form. First we have minus 3 comma 0. So how we can write here? It is a collection of all numbers where x belongs to the set of real numbers. X lies between minus 3 and 0. Since both sides we have an open interval, we have minus 3 less than x less than 0. The next thing is we have minus 3 comma 5. Again it is a collection of all values of x where x belongs to R and x lies between minus 23 and 5, but we have open interval at minus 23, that means we are including minus 23. So thus this is the set builder form of the interval minus 23 comma 5. We have a power set. What do you mean by this power set? I have already told you, for any set we can derive the number of subsets in the form of 2 to the power n, and writing all these subsets in again one more set is called the power set, and it is always denoted by P of A. Thus, the collection of all subsets in one more set is called a power set. Let me take an example. Let me consider A is equal to set AB. So how many elements are there? We have 2 elements. I have already told you the number of subsets inside the set will be equal to 2 to the power n. That means 2 to the power 2, which is equal to 4. There are 4 subsets for the given set. What are those sets? I told you empty set is a subset of every set. So therefore empty is a subset of A. Let me write the singleton sets. So A is a subset of A, B is a subset of A, and every subset is a subset of itself. That's why A comma B is also subset of A. All these sets are subset of A, and writing all these subsets as an element inside one more set is your power set. That is P of A is equal to A. Now let me take one more example. X is equal to minus 1. Now what is the power set of X? Power set of X should contain all the subsets of X. So therefore empty is a subset of every set and remaining is only minus 1. So therefore minus 1 is also subset of X. So therefore how many elements are there here? 2 to the power n 1. So which is 2. So therefore 2 elements should be inside the power set. So the number of subsets formed is nothing but number of elements inside the power set. So therefore that is equal to 2 to the power n. Now let's see now number of elements in a power set. I already told you number of subsets is nothing but number of elements inside the power set. Suppose we have a set with m elements. We have a set with m elements. The number of elements inside the power set will be equal to 2 to the power m, and it is denoted by n of P of A. That is, n represents the cardinality. Cardinality is nothing but the number of elements inside the set. So number of elements inside the power set will be equal to 2 to the power m. So here I have taken example. A set Z contains 4 elements, and then the number of elements inside the power set of Z will be number of elements inside P of Z is equal to 2 power 4, which is equal to 16. So if the set contains 4 elements, we can form 2 power 4 16 subsets. So when we can form 16 subsets and we write all that subset in one more set called power set, then number of elements inside the power set is also same, that is 16. Write down all the subsets of the following cases. What are the subsets here? We have only one element. So total 2 power 1 is 2 elements should be formed. One is empty, another one is the set itself, because every set is a subset of itself. Next we have 1, 2, 3. Let us write empty set first. Then we will form singleton sets of each element. 1 is a subset, 2 is a subset, 3 is a subset. 1, 2 is a subset, 2, 3 is a subset, 1, 3 is a subset, and 1, 2, 3 is again a subset. So finished. So the singleton sets 1, 2 is same as 2, 1. So therefore no need to write 2, 1 again. 2, 3, 1, 3, 1, 2, 3. Why 1, 2, 3? Because every set is a subset of itself again. Next we have an empty set. Empty set means there are no element inside the set. So therefore what is a power set of an empty set? Power set of an empty set is always written empty inside the braces. So this represents the power set of an empty set. Okay. Since empty set does not contain any element, every set is a subset of itself, we can write only the empty set inside the power set of an empty set. So since empty set do not have any elements, we have 2 power 0 which is equal to 1 element. So therefore, the only element inside the power set is empty set here. The next one is universal set. What is this universal set? The basic set which contains all the elements of a problem under consideration is called universal set, and universal set is always denoted by capital U. So, universal set is the basic set or the parental set where you can derive all the subsets. Suppose when I take Z as a universal set, if you take Z as a universal set, we can call whole number as a subset of Z, we can call natural number or as a subset of Z, we can call even natural number, odd natural number or prime numbers as a subset of Z. So, thus universal set can be considered as the basic trig. For all the number system, we can call real numbers or the universal set. So, U is the set of real numbers where we can derive all other types of number system. So, when I take a set of triangles as a universal set, then I can call isosceles triangle as a subset, equilateral triangle as a subset, right angle triangle as a subset of all those triangles. When I say circles, that is a circles in any plane as a universal set, circle with different radius can be taken as a subset or a sets under the set of circles. So therefore, universal set will form a major set or a basic set where the other sets can be derived, or it can be taken as a major set whenever the problems are under consideration. What universal set would you propose for each of the following? Now, looking at the given example, we need to suggest what universal set can this set take. The set of right triangles. When I say right triangles, there are only right triangles. So, therefore, the set of triangles. So, therefore, the set of triangles. When I say set of triangles, it has all types of triangles: equilateral, equiangular, scalene, isosceles, right angle, obtuse angle, the acute angle. Every type of triangles are inside the set of triangle. So, therefore, I can take this as a universal set. Similarly, for the set of isosceles triangle, I can take the set of triangle as a universal set. Next one, the set of integers. When I say the set of integers, the number system greater than integers may be a rational number or real number. So, both can be taken as a universal set because it contains integers inside it. Next, the set of rectangles. When I say rectangles, it's a four-sided planar figure. So, therefore, quadrilaterals can be taken as a universal set for the set of rectangles. So, like this, you can suggest any universal set for the given set. We'll meet you in the next session with few more concepts of the sets. Until then, keep watching, keep learning, keep exploring. Thank you.